Hello everyone, welcome to my YouTube channel. So here today we are going to be looking at a physics full paper. So as you can see, this paper is really good for any program that is related to NS. We are going to cover all these questions. So as you can see, it covers all the questions from introduction to dynamics. So we can begin. So the first one is very simple. We have how many significant figures are there in the following numbers. So if you have your 2.26 times 10 to the power negative 6, how many significant figures are there? So the number of significant figures for any number is just count the numbers that are there. Now if you have an exponent, you do not consider the exponent, just count the numbers. So in this case, the number of significant figures are 1, 2, and 3. So we are going to have 3 significant figures. Then when we look at our second one, it says that we have our 0.0053. The number of significant figures for this one are, we are going to have a 5. So the number of significant figures here are 2 significant figures. So as you can see, we have here, we are just going to count the number of the true numbers. So zeros before a non-zero number are not significant unless if we had 1.0053. Then this can be 5 significant figures because these zeros will be considered to be significant because there is a number that is a non-zero there. So in that case, we are going to have 2 significant figures. If you look at this one where we have 4.244 times our 10 to the power 8, the number of significant figures here are, we are going to have 4 significant figures like that. So that is how we obtain our 3 marks. 197% to go. This question says, a CBU student decides to paint his room that is in the form of a cube, with each side having the length of 3 meters. He ran out of paint, only managed to paint 5 sides. If 45,000 cubic centimeters of paint was used, find the thickness of the paint on the wall. So if you're looking at the thickness of the paint on the wall, this is very simple. So we have a cube like this. So if we have this is our cube. So the faces have been painted, the side face, this face on top, this face at the back, this face on top, this face here, and the down face here has been painted. So we have 5 total faces painted, but the one that is the outer covering, which is the one that you see here, is not painted. So that means to say we have the area there. Now for thickness, for anything, if you draw something, let's say like this, then the thickness of that thing, we could have something like this. Let's say we have something like this. So this in the actual sense is the thickness. So this side. Now the thickness for anything, it's only that this is not in 3D. It could be the length of that thing. So if you are looking at, let's say, a book, if this is a book, it has got pages, then the height itself, the height of the book from here, that is from here where the pages are, from here to here is your height. Now this same height is what we are going to term as our thickness. Now the thickness in the actual sense is, so therefore the volume, we know that volume is equal to L times L times L if it's a square. Therefore we are going to have L squared times our L. Now in this case, our L squared, we know that this is area, then we have L. Now in this case, this L is equal to the height. So the volume will be equal to area times height, which in this case will be, volume should be equal to area times our thickness, like that. So with this formula, we can find the thickness. Let's look at the problem now. So if we have a CBU student decides to paint a room that is in the form of a cube, with each side having the length of 3 meters. He ran out of paint and only managed to paint 5 sides of his room. If 45,000 cubic centimeters of paint was used, find the thickness. So we know to say volume is equal to area times our thickness. So we can replace, but the pressure is that the area, we have the length of 3 meters there, length of 3 meters, and we have 5 sides. So that means to say the area of one side is let's say 3 times 3, which will give us 9. That's the area. Now we have 5 sides painted, so there are 5 separate squares that have been painted. Therefore we have to account for all the areas there. So we are going to say, now this value, it is in cubic centimeters, so we need to convert this to the cubic meter. So let's convert the volume, which is our 45,000 there, cubic centimeters. We are going to have our 45,000 cubic centimeters times, we are going to have, using the chain link conversion, since the centimeter is up here, we need to cancel it. We are going to put it down here, but let's put first the bigger unit on top. So we have 1 meter cubed. So in 1 meter there is exactly 100 centimeters. Now we are going to, since there is power 3, we are going to add a power 3 there to give us a value of, we have a 45,000 cubic centimeters times 1 meter cubed, then 100 to the power 3 gives us 3 6 zeros like that. All we have to do is, so centimeter cubed, we are going to cancel the 3 zeros there. We are going to cancel like that. Then we are remaining with our 45. This and this goes over our 1000 like that. Then we have times our meter cubed. So converting this, we are going to get, so this is going to give us a 0.045 meter cubed. When we find our volume in this, then we can use volume is equal to area times our thickness. Let's find the area. Area in this case is equal to, let's find our area is equal to, we know that area is equal to L times L. Since it's a cube, it has got equal sides. So on each side there is, let's say if this is 3, this is also 3. So L times L. Now we are going to add a 5 since there are 5 parts. So we are going to have 5 times the 3 times the 3, which will give us a value of 9. 3 times 3 is 9 times 5. That will give us a 45 meter squared, since this was the meter, this was the meter. So therefore volume is equal to our area times the thickness, which we can now replace, which will give us the volume is equal to 0.045 meter to the power 3 is equal to area. Area is equal to, we found it to be 45 meter squared times our thickness, like that. Then all we have to do is divide our 45 meter squared. We divide our 45 meter squared like that. When we divide like that, we are going to have divided by our 45. This is going to give us a 1 times 10 to the power of negative 3 meters should be equal to thickness, which can be written as, so if we have power negative 3, that means we have 3 zeros, so 0.001 meters. That's our thickness in the SI units, which is the meters. Let's move on to our next question. So we have been told express the following in terms of prefixes. So if we have this number 0.000851, so what I encourage is that move closer to a pure number. So we are going to move 1, 2, 3 like that. Oh, I've forgotten 1 0. So we have 0.030. So we are going to have 1, 2, 3 like that. So we know to say there is a prefix which is a 10 to the power negative 3. So if you are moving to your right hand side there, we are going to add a negative. So this will be, since we have moved 3 times, we can say that this is a 0 point. Then we are going to say 851. like that. Then we are going to say times 10. You have moved 3 units. Now you are going to your right, so you are going to attach a negative 3 like that. Then we know to say 10 to the power negative 3 is equal to a milli. So we are going to write 0.851 milli is the small m amp, like that. So remember, this is very, very important in terms of the letter. If you write a bigger letter, that carries a different meaning, and therefore it would be wrong. Let's move on to our next question. If you look at your C2, C2 says that we have 5.44 times 10 to the power negative 13. So we have 5.44 times 10 to the power negative 13 grams. So we are going to have grams like that. Then what we are going to do is that we know that a prefix closest to negative 13 is 10 to the power of negative 12. Now this is negative 13, so the only way we can be able to move the other side is if we multiply the number by 10 to the power 1. So like this. So this is what I mean. So we have 5.44 like that. Then we have times 10 to the power negative 13 grams. What we are going to do is that we are going to move the decimal point this side, so that it adds a power 10. Remember, if you are moving this side, you are adding 1. If you are moving this side, you are subtracting 1. So we are going to have a 0.544 like that. Then we have times our 10 to the power negative 13. Then since you moved a decimal point there, you are going to multiply 10 to the power positive 1, since you are moving that other side, gram, like that. We know to say from the rules of indices, you take one base and adds the power. So if we have plus 1 there, we are going to have adds there. So we have a 0.544 times our 10 to the power negative 13 plus 1 is negative 12. Then we have the gram there. So we know to say 10 to the power negative 12 is a pico. So we are going to say this is 0.544. Then the symbol for pico is a small letter p. Then we have the gram there. So this is what they want you to write. So which is our 0.544 picogram, like that. So moving on to this other one, we have 73 million. So we are going to write our 73 million like that. So what we are going to do is that let's move at least closer to the number there. We have 1, 2, 3, 4, 5, 6, and we know to say, so this is the meter. Yeah, so we know to say it will be a 73. Then we have times 10 to the power of, as long as you move, you can show this even in your working, you have the power of 6 like that, since you are moving to your left and you add powers, so you moved 6 times. Then we have the meter. So we know that this is 73 times 10 to the power 6 is mega. So the symbol for mega is big letter M. Then we have the meter there. So that means to say you have answered that. Let's move on to our next question. This one says list 3 limitations of dimensional analysis. So the limitations of dimensional analysis are that number 1, you cannot be used to find the value of dimensionless constants. So cannot be used to find the actual values of dimensionless constant, which we call K. Like for example, if you are looking at the kinetic energy is equal to half mv squared, like that. Now, how did they know that this should be half? Under dimensional analysis, when you are deriving the equation, you say K mv squared. But this value can never be known using dimensional analysis, but can be found by experimental method. So the limitation is that it cannot be used to find actual values of dimensionless constant, like that. The second limitation to dimensional analysis is that it cannot be used to derive equations involving trigonometry. So not only trigonometric ratios, but also the exponentials and logarithms. Then the other limitation to dimensional analysis is that cannot be able to differentiate physical quantities that have the same dimensions. So dimensional analysis, just as I have said, it cannot be used to differentiate physical quantities with the same dimensions. For example, if we are looking at work and torque, so both of these, though different, is work. If you look at work, so this is just an explanation. If you look at work is the product of the force and the distance moved in the direction of the force. Torque, on the other hand, is the product of the force and the perpendicular distance. But all these are, this is force, this is a distance. So if you find dimensions, remember force is equal to ml t raised to the power negative 2 times the distance, which is your L, like that. Then if you are going to have your m like that, distance is L times L is L squared t raised to the power. Even if you do this, even if this is perpendicular distance, but it is still distance, so it is still going to give you the same things. Now if you have these dimensions, let's say after deriving an equation, you are unable to tell if this is torque or if this is work. So it cannot be able to differentiate between physical quantities with the same dimensions like that. Let's move on to our next question. If you have this other one, it says that the velocity of a particle is given by, we have the v is equal to at squared plus our bt, like that, where v is in meters per second, time t in seconds, and ab are constants. Determine the units of a by b, like that. So if we are required to find the units of a by b, what are we going to have? So firstly, we have the velocity is equal to that, time in seconds, then we are required to multiply what are the units of this. So first let's find the dimensions, then the units. So remember, under dimensional analysis, we have what we call the principle of homogeneity. So the principle of homogeneity states that only like terms can be added, equated, or subtracted. So that means to say, if we have v here, whatever is here is also equal to v, whatever is here is also equal to v. Likewise, if you're adding this, and this, that means to say they have the same dimensions, like that. So therefore, we know that v is equal to L t raised to the power negative 1. If you need more information on how we get this, you can just comment in the section and I send you a video where we cover all these. Now we know to say velocity is equal to L t raised to the power negative 1. So we are going to put it there. Then we have the time there. So let's substitute the dimensions. So this one is our L t, where there is v. L t raised to the power negative 1 should be equal to our a. Time is a dimension of t squared, then we have plus b, then we have our t, like that. Therefore, when we do that, we are going to now equate. So that means to say this and this are equal. That's the meaning of the principle of homogeneity. So we have our L t raised to the power negative 1 is equal to a t squared, like that. We divide our t squared like that. We divide our t squared like that. Then we are going to have our a. Our a will be equal to L. We have our t raised to the power negative 1. If you are dividing the same letter, take one base, subtract the power. So negative 1, then this 2, it will be minus 2, like that, which will give us L t raised to the power negative 3 should be equal to our a, like that. So these are the dimensions of a. Now to find the units of a, length, so in what? Determine the units of the quantity. So in SI units, the unit of length is meters, the unit of time is the seconds, then we have to the power negative 3, like that. So same approach, we are going to find our b. So bt is equal to also this. So we are going to have our let me just write it. LT raised to the power negative 1 is equal to, we had AT squared plus our BT. So our B is equal to that. We are going to have our LT raised to the power negative 1 should be equal to, we have our BT like that. We divide our T, then we are going to have our B should be equal to L T raised to the power negative 1. So we subtract minus 1, so our B is equal to L T raised to the power negative 2 like that. So these are our dimensions of time like that. Oh, the dimensions of B. So B will be equal to, length is the meter, then we have the time is second raised to the power negative 2 like that. So these are our units. Now they said that multiply your AB. So AB is equal to, we know that our A is equal to meter seconds to the power negative 1. So we are going to write our meter seconds to the power negative 3. Then we have times our meter, B is our meter seconds to the power negative 2. So meter times meter will be equal to, we have our meter squared, then we have our seconds to the power negative 3. Adds the powers, we have plus, but this is negative, so it will be negative 2 in brackets negative 2, which will be your meter squared seconds negative 3 minus 2, which will be the meter squared second to the power negative 5 like that. So these are the units of A by B like that. Let's move on to our next question, which says that the velocity of a particle is given by this, or not this one. We have the centripetal force F acting on a particle depends on the mass of the particle, its velocity and radius. Derive the formula for force. So the expectation is force is equal to mass mv squared over r. So this is the formula for centripetal force. So this is at least what we should expect, mv squared over r like that. So let's find this. So we are going to have our force should be equal to force depends, so we are going to say it's more like varies with the mass. So we are going to say mass to the power of A, then we have its velocity v to the power of B, then we have the radius, which is r to the power of C. So by doing that, we are going to have the force. Therefore the force will be equal to K, mass to the power of A, v to the power of B, r to the power of C. We know to say force is equal to mass times the acceleration, and the acceleration is equal to Lt raised to the power negative 2, combine it with the mass. So therefore the force is equal to m Lt to the power negative 2. So again, if you need a video on how we derived this, you can just comment in the comment section. It should be equal to K. Then we have our mass to the power of A. So let's put the dimensions for force, which is our m to the power of ml t raised to the power negative 2 should be equal to K, mass to the power of A. Then we have the velocity to the power of B, which is our Lt to the power negative 1 to the power of B like that. Then we have the radius r, which is just L to the power of our C like that. With this we can do mlt raised to the power negative 2 should be equal to K. Then we have our m to the power of A. Then we have this B can be distributed, so we have our L to the power B, T to the power negative B like that. Then we have times our L to the power of C like that. So this is going to give us a K. We have what else do we have? Does anything rely on mass? No. So we have our m L t raised to the power negative 2. We have our m to the power of A. Then what you can do here is multiply. So this and this multiplies. Keep one base, add the power. So we have L to the power of B plus C. Then we have times our t to the power of negative B like that. So all we have to do now is equate. So get this unit, equate it to this unit since it's the one with t. So we are going to have our t to the power negative 2 should be equal to t to the power negative b. This is direct. So we cancel the bases, equate the power. So we have negative 2 should be equal to negative b. We divide negative 1, our b should be equal to positive 2, like that. Same, we are going to, let's deal with the ones that can give us a direct answer. So we equate our m is to the power 1 should be equal to m to the power of a. So which gives us this and this cancel, so our a is equal to positive 1. Last but not the least, we equate this to this. So we are going to have our L should be equal to, we have L to the power of our b plus c, like that. We cancel the bases, equate the power. So 1 should be equal to b plus our c, like that. So our 1 is equal to b plus c. We are going to get a 1 should be equal to, what's our b value? B is equal to 2. So we are going to say 2 plus c. We take the 2 there, it will be 1 minus 2 is equal to c. 1 minus 2 gives us a negative 1 should be equal to c. So our a, we found our a to be equal to 1. Our b was found to be equal to 2. Our c was found to be equal to a negative 1. We get the equation which was written, which is this one. And after getting this equation, then just substitute. So getting this equation, we are going to get something like this. Our force is equal to the constant k, mass to the power of a is 1, b, our velocity to the power of 2, since b is equal to 2, and our radius to the power negative 1. So which will give us k, mass, velocity, since to the power 1, 2 over, we have our negative 1 can be written as r, positive 1, like that, which can look like this. So this is the centripetal force with a constant k that cannot be found by dimensional analysis. You get your 8 marks from there. Let's move on to our next question. Distinguish between scalar quantity and vector quantity. So a scalar and a vector quantity. So a scalar has no direction, whilst a vector has both magnitude and direction. So the definition can be a distinguishing factor. So we can define, so we have a scalar only has magnitude, whilst a vector has both magnitude and direction. So that's the difference. Let's move on to our next question. So we have this one. A bank in town A is robbed. The thieves escape from the police to town B by helicopter, making 4 successive flights described by the following displacements. So the key to this question is just come up with the correct coordinate axis, then you are halfway there. So we have 14 degrees east. We know that east is this side. We have our north, we have our south, we have our west. So our 14 degrees west east is this side, so we have our 14 there. Then what else do we have? So that's our first displacement. Our second one is 15 degrees 15 kilometers 30 degrees east of north. So try to go to your east whilst going to your north. That's the meaning. Now let's identify where the angle is. East of north means the last letter or the last thing is where you're starting from. So from the north until you go to your east until you meet the letter. So this is our 30 degrees there. Then you move on to your next one. So this can be in yellow. Then this one can be in so this one we have 15 kilometers. Here we have a 14 kilometers like that. Then we are on which one are we on? So we are on 16 kilometers at 45 degrees west of north. So go to your west, which is this side, whilst going to your north, which is up. So we have, this is what we have. Now to identify the angle that we are going to have is that we have a west of north, means begin from your north, go to your west until you meet that line. So we are going to have a 45 degrees there. Last but not the least, we have our 13. So what value was this? This was 16. So we have 16 kilometers. Last but not the least, we have what do we have? 13 kilometers at 60 degrees east of south. 13 kilometers at 60 degrees east of south means go to your south. South is down here, but at the same time be going to your east, which is going to look like this. So this is what we have there. Now when we do that, we are going to have our, let's identify the angle. 60 degrees east of south means begin from your south, go to your east. So this is your 60 degrees there. So after you have done that, so this is equal to a 13. After you have done that, you can now find the components in the x or components in the y, depending on what you are conversant with, either using the table or the direct method. As for this video, I'll be using the direct method. So we have the resultant in the x. We are going to say the resultant in the x is equal to, we are going to say, so let's have so the resultant in the x, let's call this one as our number 1, this one will be our number 2, this one will be our number 3, this one will be our number, okay, let me reverse it. We have number 1, we have number 2, we have number 3, we have number 4, like that. So we can say this will be, so let's call this one as our resultant number 1, and remember Rx is associated with the cos, then Ry is associated with sine. So all we are going to say is R1 attach the cos of theta 1 plus R2 cos of theta 2 plus R3 cos of theta 3 plus our R4 cos of our theta 4, like that. So our R1, what is our radius, our distance number 1? Distance number 1 is 14. 14 cos of our theta is equal to, we have this one along this line, we have the theta is equal to either 360 or a 0. So we are going to use a 0. So 0 degrees plus, we have our R2 is equal to 15. So we are going to say 15 cosine of theta. Now we are taking the theta from the positive x-axis, so from this point to where it meets. So we are going to have, so this distance, this angle is 60 degrees because we have a 90 degrees like that. So if we have a 90 degrees like that, this 90 degrees, if this part is 30, then the complementary part will be 60 degrees, which you can find by saying the theta should be equal to, so if you have theta plus our 30 degrees plus our 30 degrees should be equal to 90, because if you add 30 plus whatever angle is here, it will be 90. So theta will be equal to 90 minus 30, which will give you 60 degrees. So we are going to say plus our 60 degrees plus, we are going to have our R3. Our R3 in this case is equivalent to, we have a 16 there, so we can say 16 cos of, what is the angle measured from the positive x-axis. So we are looking at, let's just draw a small diagram. So we are looking at this angle that is here. If here, from here to here, it's 45. Now we want it from the positive x-axis to here. So this angle will be equal to, we have 90 degrees plus our 45 degrees, which will be 90 plus our 45 plus our 45 degrees will be equal to 135. So we are going to say 135 degrees, which we are going to put here, 135 degrees. So we have 135 there. Then we are going to add plus our last value, which is our 13. So we are going to say 13 cos of, measured from the positive x-axis, that angle will be from here, it's 60 here, from here until we reach that point, not the complete circle. So from here up to here. So we are going to say, if from here up to here it is equal to, or from here up to here it is equal to 270. So we can take a 270 there, we add it plus this 60 degrees, which will be equal to, should be about 270 plus 60 degrees. This is going to give us a 330 degrees. So from here up to where the 60 is 360, because from here up to just here it is 270. You add, it will be 330. So we are going to say 330 degrees like that. So if you look at your 14 cosine of 0 degrees, you are going to have a 14 like that kilometers. So this is in the Rx. Then we have our 15 cosine of 60. This will give us a value of 7.5. So we have 7.5. Then we have plus our 16 cosine of 135, which is a negative, in fact, negative 11.314. Then we have our last but not the least 13 cosine of 330. This is giving us a value of positive 11.26 like that. So our Rx will be equal to, we add our 14 plus 7.5 plus our minus our 11.314. Then we have plus our 11.26. This is going to give us a value of a 21.446 like that. So same approach, you are going to find your Ry. So Ry should be equal to, you are going to use exactly the same, which is your R1 sine of theta 1 plus our R2. Now the only thing that is changing is the sine of theta 2 plus our R3 sine of theta 3 plus our R4 sine of theta 4 like that. So now what I'm just going to do is that I have found everything, so all I have to do is substitute. So just by comparing that equation, so I'm going to say it will be my 14, where there is sine, I'll say sine, the angle is the same, 0 degrees, plus my next value is a 15 sine of, the angle there is 60 degrees, plus my 16 cosine of, sine of, so the Ry is associated with sine of our theta 3 is equal to 135 degrees. Then we have plus our R3, which is our 13 sine of our 330 degrees. So our Ry will be equal to, we have our 14 sine of 0 degrees, we are going to have 0. Then we have plus our 15 sine of 60. This will give us a value of 12.99. Then when we add plus our 16 sine of 135, this is going to give us a value of 11.314. Then we have plus our 13 sine of 330. This is going to give us a negative So we cancel this, negative 6.5 like that. So our ROI in this case will be equal to, we have 12.99 plus 11.314, then we have minus 6.5. This is going to give us 17.804. So with that, we have RY is equal to that, so we can just indicate Rx is equal to, we are going to have 21.446. Then we have our RY should be equal to 17.804. Then all we have to do is that we are going to find our now displacement, which is our displacement can be found by finding the square root of our Rx squared plus our Ry squared, like that. So we are going to have something like this. Our Rx was found to be 21.46446 squared, then we have plus our 17.84 squared, like that. So when we find the square root of this, it will be the square root of our 21.446 squared plus our 17.8 squared. If we add those two, we are going to get a 776.771. So the square root of this value will be found to be a 27.87, like that. So this is the displacement or the magnitude, what is the direction and how far will the helicopter travel in this flight. So that is the answer there. Then the direction, we are looking at the angle. So if you look at this, we had two things. So these two things are, firstly, 21.446, 21.446 there, which is 21.446 is in the x. So let's say if we have a 25, so 21.446 is somewhere here. Then we have our 17, which is positive. Let's say we have 18 there, so 17 point something will be there. So this is our resultant displacement drawn like that. So we want the direction measured from the positive x-axis, meaning this direction. So to find the direction, we use the tan of theta should be equal to, we are going to have, if the angle is here, opposite side is your y, which is your Ry, over your Rx, like that, since tan is opposite over adjacent, like that. Then we have opposite, which is your height, over the x, like that. So the tan of theta should be equal to, what is our Ry? Ry is equal to, we have a value of Ry is equal to 17.804 over our Rx is equal to 21.446. So our theta will be equal to tan inverse, if we take the tan there, tan inverse of 17.804 over 21.446, like that. So our theta should be equal to the tan inverse of, we have 17.804 divided by 21.446. The value that it's giving us is equal to a 39.7 degrees. So this is the direction. So magnitude we found it to be 27.87. Direction is the angle, so direction is equal to 39.7 degrees, like that. So this one we have, find the values of a for which vectors a, we have a is equal to ai plus minus 2j plus our k, and b is equal to, we have our 2ai, then we have our aj, then we have plus our 4k, like that. Then we are told that they are perpendicular to each other. So if two vectors are perpendicular to each other, meaning to say they are meeting at 90 degrees, their dot product is equal to 0. Therefore, our A dot of B should be equal to 0. So our A is equal to, we have our AI minus our 2J plus our K like that. We multiply it with our B, which is our 2AI. Then we have plus our AJ. Then we have plus our 4K. This should be equal to 0. So remember, if two vectors are perpendicular to each other, their dot product is equal to 0. Then if we have this, all we have to do is that multiply the like terms. So let A multiply with let the one with I multiply with the one with I. So this and this, we are going to have our 2 A times A, it will be A squared. Then forget about this. Likewise, let the one with J multiply with the one with J, which will give us this. The one with J, let it multiply with the one with J. So we have our negative 2 times A, it will be negative 2A. Then we have J times J is just 1. Then we are going to have, last but not the least, let the one with K multiply with the one with K. So here we have 1. 1 times 4 is equal to 4. Then we have, this should be equal to 0. If we have a common number, we can divide it throughout, so that we remain with our A squared minus our A. Then we have plus our 2, like that, should be equal to 0. Then we can use either the quadratic formula, or we can just factorize if possible. So factorizing this, we have factors, we have the product. So product is equal to AC. So if this is our A, B, C, AC is equal to our coefficients. We have 1 there, we have 2. So we are going to say 1 times 2, which is going to give us 2. Then our sum, which is equal to the coefficient of P, which is equal to negative 1, like that. So we have a negative 1 like that. Then we have our factors. So our factors in this case is equivalent to the two numbers, which when we add them, they are going to give us a negative 1, but when we multiply them, they are going to give us a 2R. Oh, sorry. Let's look at here. It's minus. Didn't see this minus there. So we have minus 4K. So we are going to have here, it's supposed to be minus, according to the question, minus. But if it's not working, the factorization method, you can just go for the quadratic formula. So these two numbers, which when we multiply it's negative 2, but when we add it's negative 1, are negative 2 and positive 1. So replacing these values, we are going to have our A like that, A squared. Then we have minus, we put this negative 2A plus our A. Then we have minus our 2 should be equal to 0. So our A is common here, so we are going to have our A, open brackets, A minus our 2 like that, since A is common there. Then this side we are going to have the common between A and 2 is positive 1. Then we have our A minus 2. So pick one bracket, so we have A minus 2, we have A plus 1, which is equal to 0. So we are going to say A minus 2 is equal to 0, or A plus 1 is equal to 0. So our A is equal to positive 2, or our A is equal to negative 1, like that. And that is how we score our 6 marks. If A is equal to this and B is equal to, then we are asked, find a unit vector perpendicular to both A and B. So how do you find the unit vector perpendicular to A and B? So if A is equal to, we have our 4I minus J plus our 3K like that. Our B is equal to 2I. Then we have plus our J minus our 2K like that. Then find a unit vector perpendicular to both A and B. So the vector that is perpendicular to both A and B, don't get this confused. We are looking at the cross product. If they say if two vectors A and B are perpendicular to each other, that means they are just two vectors. that means their dot product is equal to 0. However, when we are looking at this, if we are looking at find a unit vector perpendicular, so if you are looking for a vector that is perpendicular to both A and B, you are looking at the cross products. Like for example, if let's say we have our A and B might not even be perpendicular to each other. If you have your A and your B, then there is another vector that is perpendicular to both A and B. So meaning we have a 90 degrees, we have a 90 degrees, then that vector is the cross product, sometimes termed as your C, which is your A cross of B. So the vector that is perpendicular to both A and B is the cross product. But if A and B are perpendicular to each other, that means to say you are looking at the dot product. So that is the main difference. So provided with that question, well, we are looking at a unit vector. So a unit vector is a vector of unit 1. First, let's find the vector that is perpendicular to both A and B. So to find that vector, we are going to say A cross of B should be equal to, remember, we are going to say our I, our J, our K, like that. So we have our I, our J, our K, like that, which is going to give us a value of, what is our I? Our I, or our L, let's begin with our 4. The coefficient of this is -1 and 3. So we have 4, -1, then we have a +3 like that. Then here we are going to have 2, 1, -2. So the coefficients are 2, 1, -2. Let's just confirm. So 1 there, -2 like that. Then to find the cross products, we are going to use plus, minus, plus. If you want, you can use minus, plus, minus. These are the signs that you are going to put to your I, your J, and your K. So the first thing that we are going to do is that we are going to cancel this. We are going to, if let's say we take away this, what are we going to have? So the point of intersection is I. So beginning with positive I, we are going to have positive I like that. Then write what is remaining. We have a -1, -2. We have a 1 and a 3, which is not cancelled there. Then after that, we are going to have after that we are going to have our minus J like that. Then we are going to say why J, because when you come here now, you cancel like that, you cancel like that. So the point of intersection is J. Then what is remaining? So it's only that. Here we have a 4. So here we have a 4. So we are going to say 4, 3, -2, and a +2 like that. Then we have plus our K, plus K. Then we are going to cancel out the last part. So okay, let me just rewrite these values. So now what do we have? We have the last values. So we are going to do the same. We cancel out like that the last part. The meeting point is K, positive. Then we are going to write our 4, -1 like that. Then we have our 2, +1 like that. So this is what we have. So we are going to say I. Then we are going to find the determinants, negative times this, -1 times -2 like that. Then say minus 1 times your 3. So this is what we are going to be doing for all these. But now I can just go direct, since now you know how we are going to be doing this. Multiply this, subtract. So we are going to have our open brackets, 4 times -2 is -8, minus 2 times 3 is 6. Then we have plus our K like that, which will give us, let me just write plus K down here. Then we have plus our K. Then we have 4 times 1 is 4, minus 2 times -1 is -2. So be careful, -2 like that. Then what we are going to get is our I. -1 times -2 is +2, minus 1 times 3 is 3. Then we have minus our j, our negative 8 times minus 6. This will give us a value of negative 14 like that. Then we have plus our k, we have our 4 plus 2 like that. Okay, so we have negative 14. Sorry for that. These minor mistakes because of the repetition of the question. Here on B we have a negative there, so we need to put it there, which means we are going to have a negative 2. The good part is that we have only used it once, so we are going to correct here. So we are going to have our negative or minus, so this will be negative, since if we take out j, we're remaining with 4, negative 2, 3 and negative 2. So we have minus there, then 4 times this is negative 8 minus our 3 times negative 2 will give us negative 6 like that. So after correcting that, we are going to have our, so here I can just do it like this. So we have negative 8 plus our 6, which will be negative 8 plus 6 will give us a value of, so here we are going negative 8 plus 6 will give us a value of negative 2 like that. Then we have plus k like that. So each and everything is okay there. Then we are going to just open the bracket. So we have I, 2 minus 3. This will give us a negative 1 like that. Then we have minus, negative times negative is positive. 2 times j, it will be 2j like that. Then last but not the least, 4 plus 2 will give us 6. So we have 6k like that. Is it 6k? Just because of that simple mistake, it has complicated things. So when we took out k, we were remaining with a negative 4, negative 1, negative 2, 4, negative 1, negative 2. So we are going to have a positive here. So we have like 4 times this is 4, which is here. Negative 2 times negative 1 is positive 2, but we have to subtract. That means to say here we are going to have a negative. So we have a negative. So 4 minus 2 is a 2. So we are going to have 2k like that. So after we have corrected, we have our negative I like that. Then we have plus our 2j like that. Then we have plus our 2k like that. So this is our A cross of our B like that. So after finding our cross product, A cross B is equal to this. So what we are going to just do is that we are now going to find what are we told? We are now going to find our unit vector. So a unit vector is that vector over its magnitude. So we have, if we are looking at the unit vector, it will be equal to the vector itself, which is our A cross of B, over its magnitude, which is just over A cross of B like that. So this is our unit vector, that vector over its magnitude like that. So the magnitude of this vector A cross B, the magnitude of A cross B will be equal to the square root of, we have our x squared plus our y squared plus our z squared like that. So our x squared is equal to, if we have our x squared, we are going to have negative 1 squared plus, we have our y squared, which is our 2 squared, plus our z squared, which is our 2 squared again. This is going to give us the square root of negative 1 squared is 1 plus 2 squared is 4 plus 2 squared is 4, which is the square root of our 9 like that. Square root of 9 is 3 like that. So this is our magnitude of the cross product. So the unit vector, we have said that it is equal to that vector over its magnitude. like that. So we can write our A cross B will be equal to, so A cross B is equal to, we have our negative I, so which is this one. We can just lift it, so we have our that one which we are going to put, so this vector over its magnitude, and the magnitude is equal to positive 3, which can be split as negative I over 3 plus our 2j over 3, we have plus 2k over our 3, which can be separated as negative 1 over 3i, then we have plus 2 over 3j like that, then we have plus our 2 over 3k like that. So this is the unit vector they want to obtain your 6 marks there. Let's move on to our next question. This question says, in figure 3.1 shows the velocity time graph for the particle moving in a straight line. Calculate the displacement from point A to E. So from point A to point E, so to find the displacement, just identify the shapes that are there. So from point A to E, so from here up to E, we are going to find. So there are many ways of doing this question. So all you have to do is split. If you want, you can take this one as your area number 1, which is the square like that. You take then the area number 2, you can take this thing, then add up the areas, then this would be your area number 3. This approach can work as long as you know to say this is a trapezium, from here up to here it's a trapezium. So in whichever way you use, it is still going to work. Now to answer this, let's use the simplest one. Looking at this shape, we can do this. So this is the area of that. So when you're answering this one, you will have to draw a simple thing to just show them the area that you are using. So let's use this area and the area from here up to here, which is a rectangle. So area number 1 is a trapezium, area number 2 is a rectangle. So we can say our area number 1, area 1 will be equal to, we know that a trapezium is half our A plus our B, then we have our height. Then we are going to have our half. What is our A? Our A is equal to, so from A and B are always parallel to each other, so these sides that run in the same direction are A and B. Let's take A to be the shortest one. So from, if we have something like this, so from here up to here, that's your A, then your B is the one down there. So they are always parallel to each other. That means to say, even if you were to use this other one, let's say you were to use the trapezium up here, that means to say your A and your B always has to be parallel to each other like that. So in this case, we have our A from here up to here. It is known that from here up to here it is equal to a 2. So we are going to have, so from here up to here it's 2. So we are going to say 2 plus our B from here up to here, it is equal to 3. As you can see, it's the distance from here up to here, it is equal to 3. So we are going to say 3 times the height. Now the height from this point to this point, it is equal to, so if from here to here it's 2, then from here to here it's 4. So to find the height h, it is the difference between the two, which will be 4 minus 2, which is a positive 2. So we are going to have a positive 2 like that. This and this cancels, then we are going to have 2 plus 3 is 5. So our area number 1 is 5. Then area number 2, which is from here up to here, so this shape, so this is our A2. In which case we are going to say area number 2, this is a rectangle. So we are going to say this will be our L times our B, or our L times height, whichever. So our L is equal to, we have L, which is equal to, from here up to the last value it's 5. So we are going to say 5 times our H, which is from here up to here, it is going to be 2. So we have 10 like that. So this is our area number 2. Then to find the total area, which is equal to the displacement, we are just going to add our 5 plus our 10, which is going to give us a 15 meters like that. So we have 15 meters, since it's in meters per second, so the displacement will be 15 meters like that. So we have a person stands at the edge of the straight 20 meters high cliff and throws the ball directly upwards with an initial speed of 5 meters per second. Determine number 1, vertical distance reached by the ball measured from the base of the cliff. Number 2, how long will it take the ball to hit the ground at the base of the cliff? So we are going to have something like this. So if this person is stands at the edge of a straight cliff that is 20 meters high. So from here up to here, we have a cliff that is 20 meters high. Then what we are going to have is that a person stands at the edge of the straight 20 meters high cliff and throws the ball directly up at an horizontal speed of this. Then we are asked the vertical distance reached by the ball measured from the base of the cliff. First, we need to find how high did it rise from the cliff. We have the kinematic equation V is equal to U plus our AT. Then we have our V squared is equal to U squared plus our 2AS. We have our S is equal to UT plus our half AT squared. Well, the equation that we are going to use is the one for where we have enough information. We have been told that the initial we have been given, so let's look for the one that has got the initial. So it's either this or this or this, but we don't know the time it will take, which eliminates these two equations and this one, so we are going to remain with this. So to find the distance, so V squared is equal to U squared plus our 2AS. So our velocity, final velocity, the only reason why a particle stops moving is simply because all its kinetic energy has been used up, meaning to say at that point when it is stationary, the velocity is equal to 0. That is the final. So we are going to say 0 meters per second squared should be equal to the initial velocity. We have been told that it's 5 meters per second. We square this plus we have our 2. Now immediately it was thrown up, the gravity was acting downwards, so we are going to have a negative gravity. So we are going to say negative 9.8 times our S, which is our height. We are going to just say S like that. So we can say 5 squared is 25 meters per second. You can even remove the units. 2 times that, we are going to have 19.6 S. We take the 25 the other side. Here we have 0. 0 squared is 0. We have negative 25 should be equal to 19.6 S over 19.6 over 19.6. So we have negatives. So our S should be equal to, we have a 25 divided by 19.6. This is going to give us a value of a 1.28 like that. Then to find the distance from the base. So distance from base, you can write it in full. Distance from base should be equal to the height of cliff plus the height reached. That is height reached from cliff. So the height is 20 meters, that's the height of the cliff, plus this additional height of 1.28, which will give us a value of 21.28 meters. Okay, so let's look at our next one. It says that how long it takes the ball to hit the ground at the base of the cliff, 20 meters below. So if we have 20 meters below the cliff there, now remember the displacement is the change in position. We don't care, yes, it went up, but we don't care. We are just interested in where did it begin and where did it end. So it began here, and it reached here. So the separating distance here is 20 meters. So that's the displacement we will use. The displacement is the change in position. We don't care where the object went. So therefore, we are going to, now since it went up, we are going to consider it to be positive. So at the initial point when it was thrown, the gravity was acting downwards. So therefore, we are going to assume that the gravity is negative at all points, even if it begins to fall, because with respect to where it began, it was negative. Then whatever distance is below the throwing point, in this case, it will be considered to be negative. So this will be negative 20. Displacement has got both magnitude and direction like that. Therefore, we are going to say how much time, what are we taught? How long it takes the ball to hit the ground at the base of the cliff. So to find this, knowing that the kinematic equations that we have, we don't have the final speed, so we are going to use the one that has got the initial speed. Then we have our s, we have everything, we just don't have time. So let's use this equation. So using this equation, we are going to say our s should be equal to ut plus our half at squared. Our s is equal to negative 20, should be equal to initial was 5, then we have t, then we have plus half. Our a is equal to negative 9.8, then we have our t is unknown, so t squared. We are going to get negative 20 should be equal to 5t. Negative times that, it will be negative half times 9.8 will be 4.9 like that. Then we have t squared. Let's take things there. We have our 4.9 t squared minus our 5t minus our 20 like that. So when we do that, we are going now to use the quadratic formula. So our t is equal to negative b plus or minus the square root of b squared minus our 4ac over our 2a. So our t should be equal to negative, what is our b? Our b is equal to negative 5 plus or minus the square root of our b squared, which is equal to negative 5 squared minus 4. Our a is 4.9, our c is negative 20 like that. Then we have over our 2, what is our a? Our a is equal to, remember this is our a, b, c. Our a is equal to 4.9 like that. So our t is equal to, negative by negative, it's positive, so it will be positive 5 plus or minus the root of negative 5 squared is 25. Then we have plus, since this and this are multiplying, plus we have our 4 times 4.9, that will give us a 4 times 4.9 will give us a 19.6 times 20. This will give us a 392 like that. Then we have over this times this will give us a 9.8 like that. So our time will be equal to 5 plus or minus the square root of our 25 plus 392. This is going to give us a 417 like that. Then we divide this over our 9.8 like that. So square root of 417 is equal to, we have, so t is equal to 5 plus or minus the 20.4 like that over 9.8. Now if this value is bigger, we are going to just consider the positive. So t is equal to 5 plus 20.42, since time cannot be negative, over 9.8. So our time will be equal to, we have plus, if we add that 25, this plus this is 25.42 divided by 9.8, this is going to give us a value of 2.59 seconds. So this is the time it will take for it to strike there. Let's move on to our next question. Our next question is very interesting. We have an apple is shot with a velocity of 45 meters per second at an angle of 50 degrees with a horizontal. A person standing on the level ground 150 meters away from the launch point throws a ripe mango vertically towards the minimum away from toward upwards with the minimum initial speed necessary to meet the path of the arrow. At what speed does the mango leave the assistant's hand? So this person is 150 meters away. So the ability to create pictures is what is important in physics. So we have the arrow, it's moving like that. Then this arrow, what we have is that if we have the arrow there, then what we are going to have is that this person has to throw the mango so that it hits it is stopped in tracks by the arrow like that. So what we are going to have is that we will need to find certain things. Now the thing is that we have the distance, it is 150 meters. So the first thing that we are going to find is that let's find the time it will take for the arrow to move from this point to cover a distance of 150 meters. Now remember, under projectile motion, if air resistance is ignored, the acceleration in the x-axis, in the x direction, is 0. So therefore we are going to use the equation which is for the range. Distance in the x is the range, and we know to say the range. So let's first find our velocity in the x and the velocity in the y. So Vx is equal to V cos of theta. So the velocity in the x is associated with cos. So our Vx will be equal to, what is our Vx? So we have 45 meters per second. Then we have the cos of, what is our theta? Our theta is equal to 50 degrees according to this. So when we press, we are going to have 45 cos of 50 degrees. This is going to give us a 28.93 meters per second. So this is our Vx. Our Vy on the other hand will be V sine of our theta, which is 45 sine of 50 degrees, which will be 45 sine of 50 degrees. This is going to give us a 34.47 like that. So this is our Vy. Then to finally find our V should be equal to the square root of Vx squared plus our Vy squared. When we do this, we are going to get our Vx, it will be 28.93. Then we square this plus our Vy, which is our 34.47 like that. We square this, so our V will be equal to, so when we square that value plus 28.93 squared, this is going to give us the square root of 25.26. So if we find the square root of this value, we are going to get our V. What are we finding? Sorry for that, lost in track. It's giving us a 45, which is expected because the velocity of projection was 45. Sorry for that. So when we do that, we just wanted to find the components, not what I began to do there. When we do that, we can now, let's find the distance moved or the time taken to move. So our Rx, we have the range, and we know that the range is equal to Ux times time. So Ux, it has got the time. Range, we have been given that it's 150. Range is the distance in the x, which will be equal to, we have 150 meters should be equal to, our Ux is equal to 28.93 times time. We divide over 28.93 over 28.93. So our time will be equal to 150 divided by 28.93. This is going to give us a value of 5.185 like that. So this is our this is the time it will take for it to move from this point to where the 150 meter mark is. So from here up to here, it will take 5.185 seconds. So if it will take that much time for it to travel from that to that, we are just going to say, therefore, let us now, we know the time, now let's find what height, because the height at which the arrow will be at this point will be the same height the mango will have to more like be raised. So let's just find the height of the mango, since the height of the arrow from this point to where it will be in terms of the y direction. Whatever y will be, it is the same distance that the mango will have to travel. That means to say we have found that distance. Therefore, we are going to say to find the distance in the y, we are going to say our sy should be equal to, now knowing that we have the time, we have the kinematic equations, v squared is equal to u squared plus our 2as. We have our v is equal to u plus our at. We have our v is equal to u plus at. So we want the one with s and as time, which is which one? Sir, written the same equation twice. So we have our s is equal to ut plus half at squared. This has everything. So we are going to say ut plus our half at squared. So we have our y there. So our sy in this case, sy we don't know, should be equal to our initial velocity for the arrow is 34.47. So we have 34.47 like that. Then we have times, what is our time? Our time is equivalent to 5.185 seconds. Then we have plus our half. Our a is equal to negative 9.8, since when it was thrown up, the gravity was acting downwards. Then we have times our time. Our time is equivalent to 5.185. Then we have to square this. So this squared. So we are going to have our 34.47 times 5.185. This is going to give us a 178.73 like that. Then minus, we have half 0.5 times 9.8. This is going to give us a 4.9 times 5.185 squared. This is going to give us 131.73 like that. Then when we subtract sy, okay, so this is too much rounding off. Okay, anyways, still okay. So we have 178 minus 131.73. This is going to give us a value of 46.997 meters. So the arrow will be so from here, the arrow at that point will be more like, it will be at the mark where it is 46.997 meters from the ground. That means to say this is the same distance that the mango has to be able to travel in terms of up, because remember this is sy, meaning that's the distance in the y moved, or rather that's the distance in the y at that point. So we are going to say, knowing that that's the distance, now we now know what distance has to be covered. Now the key term to this question is that they have told you to say what is the minimum initial speed necessary. Minimum initial speed means it should just be able to more travel a distance of 46.99 up, and then from there it should stop. So the particle has to move. It moves from here, goes like that. When it just reaches this distance, the velocity has to be converted to other forms and become 0. That's why it's stopping to move. That's the meaning of the minimum initial speed. So with that said, we have this. So the kinematic equations again, v squared is equal to u squared plus our 2as. We have our s is equal to ut plus our half at squared. We have our v is equal to u plus our at. So we need to find the minimum initial speed. Which one are we going to use? We have the distance. It should more like be able to rise. So knowing that, which equation are we going to use? We are going to this equation. Why? Because we don't know the time. So we don't know the time for the mango, but we know the time for the arrow, but we don't know the time for the mango. So we can use this to find out what is the minimum, because the maximum, at the maximum height, the velocity is equal to 0 at that point. So with that said, we are going to use our v squared is equal to u squared plus our 2as. Then our v final is equal to 0. What is our initial speed? Initial speed is unknown, so u squared plus our 2. It was thrown up, meaning the gravity was acting downwards, which will be negative 9.8 times, what is our s? Our s is equivalent to, what do we have? S is equivalent to 46.996, like that. So this is going to be 0 is equal to u squared minus, then we have our 46.997 times our 9.8 times 2. This is going to give us a 921.1412. So we take this the other side, it will be our negative u squared should be equal to negative 9.921.1412. So this we divide by the negative, so u squared is equal to 921.1412, which will be the square root of this value will be equivalent to y should be equal to, the square root of this value will be equal to 30.35 meters per second, like that. So after doing that, we are going to have this is the minimum speed that it must be thrown, like that. So we get our 8 marks there. Then we have at what time after the arrow launch should the mango be thrown so that it is hit by the arrow. So now from here we need to first know what time does the mango take to reach the height of that height. What time does it take? So let's find the time. Knowing our s is equal to ut plus our half at squared, then we have our v is equal to u plus our at, like that. So knowing our v squared is equal to u squared plus our 2as, so if you want, what do we want? We want the time it will take. If you want, you can use this equation, which is still okay, but that would be able to complicate things. Just use this to find the time. So we are going to have v should be equal to u plus our at. Our final velocity of the mango at the maximum height is 0, should be equal to, we have our u. Our u is equal to, what do we have as u? U initial, we have found it to be 30.35. Then we have plus our acceleration is negative. Remember, it's the acceleration due to gravity, and if you throw something up, it is opposing, so it's negative 9.8 t, like that. We take this value this side, it will be negative, or let's take the other value the other side. So we take this the other side, it will be positive 9.8 t, should be equal to 30.35. We divide 9.8, we divide 9.8, our time will be found to be, so our time will be found to be equal to our 30.35 divided by our 9.8, this is going to give us 30.097 seconds, like that. So this is our time. So this is our time, like that. Then if this is our time, all we have to do is that we know that it takes 3.097 seconds for the mango to reach that height. Now let's compare. If you look at the arrow, it will take 5.189. So let's say if this is the arrow, like that, so this is the illustration that we have. So we have to more like first throw the arrow, since it takes more time. Then when it reaches a certain period of time, that's when now you can throw the mango. That's the meaning, so that the two can more like be able to collide, like that. So we first have to wait for the arrow to cover some time. Now how do you find that time? So time to throw, you are going to just say this shall be equal to the time taken for the arrow, time taken for arrow, minus time for apple, for mango to reach the same height, which will be equal to, we have a 5.185 seconds minus our 0.97 seconds. So when we subtract these two times, we are going to have minus 5.85, like that. So the time we have to throw this is a 2.09 seconds. So that is the time. You have to wait for this, so that when it reaches at some point, then you throw. That is the time. So time to throw is after 2.09. So after this time, you can now throw. Let's look at our last set of questions. So we have a ball of mass M1 and a block of mass M2 is equal to that, attached by a lightweight cord that passes over a frictionless pulley of negligible mass, as shown in the figure 4.1. The block lies on the rough incline of angle theta is equal to 37 degrees. The coefficient, what else are we given? Frictionless pulley, as shown. The block lies on a rough incline at an angle of 37 degrees. The coefficient of kinetic friction between the block and the incline is a 0.25. Determine the magnitude of the acceleration of the two objects and the tension in the lightweight cord. So what we are going to have is, if we have something like this, then we are going to do this. So this is what we have. Then all we have to do is, we are going to do this. Then what we have is that we have the angle theta there. We have it's going up according to the arrows. Then here it's going down, like that. Then all we have to do is to get our free 13 marks, let's come up with equations. So now we are going to isolate the system as if it is isolated. That is how we draw the free body diagram. So begin with your free body diagram. So if let's say this is our mass number 1, this is our mass number 2. So we are going to say free body diagram for M1. So we are going to have, this is our M1, like that. So we have our M1. Then on top there, we are going to have our tension, like that. So this is our tension. Then what we are going to have is that for this equation, since we are saying that let's take up to be positive, because we know that that's where it's going. So we are going to use Newton's second law, which is the summation of forces. In this case, it's in the y, since it's going up or down. In the y is equal to ma. Now in this case, it's m number 1 a, like that. The one that is more like supporting this is the tension. So tension is in the same direction as the positive. So we have tension minus the weight is pulling down. So we have our m1g, which is the weight. m1g should be equal to m1a, like that. So we have done that. Then the free body diagram for this other one is a bit critical. So we are going to have something, it's like this. So we are going to have something like this. Then here we have our theta, like that. So all we have to do, is it alpha or theta? Okay, theta. So all we have to do is just draw your normal. I have taught how to derive this in another video specifically for this. So we have our F, the normal force, over, we have, if you extend the normal force, you are going to have your m1, m, whatever is there, m2g in this case. Then you are going to attach the cos of theta, like that. Then the weight of the objects will be concentrated at an angle. Since it's slanting like that, the object has got the possibility of rolling down, meaning to say its weight is fixated at a slant angle going down. Likewise, this force that causes the objects to go down can also be what we are going to call our m2g sine of theta, because there is always a force that will be trying to pull the objects down the incline. It will want to go up, down than to go up. So this is the force, like that. Then what have we been told? We have also been told that the block lies on a rough incline. The coefficient of kinetic friction between the block, so there is friction. So if it is going in this direction, that means to say the friction is a resistive force. It should be opposing the direction, like that. So if they haven't given you the direction, you can just assume that it's going like this. If it gives you the acceleration to be negative, let's say -3, it means to say the actual orientation is that it was going in the other direction, which is still okay. All we want is the orientation. So we are going to have something like m2g sine of our theta, like that. Then the frictional force will be in the other direction, which will be the frictional force, since it's going like that. If it was going up, the frictional force could be acting in the other direction. So that is how we draw that. What else do we have? The tension, the rope, it is connected this side, so tension will be pulling in the direction it is connected, so it will be like that. So this will be our tension, like that. Then we are going to begin by saying our summation of forces, let's begin with our y, should be equal to, now in the y direction, it is not entering the incline, so like this. So it is always in contact with the incline. Therefore, the summation of forces in the y is equal to 0. So this is because, yes, you might think that it's going up or down, but it's always in contact. It's not like that. It's not like that, but it's always in contact. So the summation of forces in the y is equal to 0. Therefore, we are going to say 0. Then what forces are those? The normal force minus the line you extended, which is your, so this line, which is your m2g cos of your theta, which should be equal to 0. So your normal force should be equal to, if this goes the other side, we have m2g cos of theta, like that. Therefore, if that's the case, we are going to have we have done that. Then we also know to say the frictional force. So after you find the normal, find the frictional force is equal to the coefficient of kinetic friction times the normal force. So the frictional force should be equal to the mu k times the normal force. In this case, it's mg cos m2g cos of our theta, like that. So that is how we deal with that. After you are done with the summation of forces in the y, go for the summation of forces in the x direction, which is equal to, now in the x direction it was moving like how we showed it, it's moving up or down in terms of the incline, but that's in the x, so it will produce an acceleration which will be your ma, like that. In this case it will be your m2a. So this is what we have. So the summation of forces in the x, so knowing that it's going down, let's take whatever is going down to be positive. So we are going to begin with our m2g sine of our theta minus the one that is opposite is the frictional force minus the tension, should be equal to the m2a, like that. So summation of forces, so the one that is going down, in which the direction is supported, we begin with that, subtracts whatever is in the opposite direction. In this case it is the tension and the frictional force. After you are done with this, get this other equation which we found here, then all you have to do is, it's either you can add them or you can add them or you can equate them, anything is okay. So for this one, the tension is negative, this one is positive, so cancel them. We are going to have our m2g sine of our theta, then we have minus the frictional force, like that. Then we are writing m2g minus this, we are combining, so it's more like we are adding the two equations. Then we have minus our m1, like that. M1, this should have been m1g, like that, should be equal to, this side the only thing we have is m2a, so we are going to say m2a plus the m1a, like that. Then all we have to do is write the frictional force. Frictional force, we found it to be mu k m2g cos of theta, write it, very important. So we have our m2g sine of theta minus mu k m1, is it m1? No, m2g cos of theta, is it? Yeah, cos of theta, like that. Then we have our m1g should be equal to m2a plus m2 plus m1a. From here, factorize this. So we have here m2g sine of theta minus mu k m2g cos of theta, then we have minus m1g, then should be equal to, the common thing here is a, then we have we are remaining with m2 plus m1, like that, which will give us over our m2 plus our m1. We divide even this side, our m2 plus our m1, like that. So this and this cancels, so our a should be equal to our m2g sine of our theta minus our mu k m2g cos of our theta minus our m1g, like that. From here, now just substitute, so your m2 plus your m1, so we have our a should be equal to, what details do we have to substitute? So what do we have? Yeah, so we can now substitute. Our m2 is equal to, we have 10, our g is 9.8, so let's use brackets, 9.8, then we have the sine of our theta is equal to 37 degrees minus our mu k. Our mu k is equal to, we have what do we have for mu k? 0.25. Then we have times our m2. Our m2 is equivalent to, we have is it? Yeah, m2 is equal to 10. Then we have our g is 9.8 cos of our theta, which is 37 degrees minus our our what? We have minus our m1, which is a 2. Okay, minus our 2, then we have 9.8 over m1 plus m2, which is a 10 kg, plus our 2 kg, like that. This is going to give us a value of, so let me move this a bit. So this is going to give us a value of A should be equal to, we have a 10 times 9.8 times the sine of 37. This is going to give us a value of our 58.97787. Then we have minus 0.25 times our 10 times our 9.8 with the cosine of 37. This will give us a value of 19.56657. Then we have minus 19.62 times 9.8 is 19.6, which will be over, we have our 12 kg, like that. So our A is equal to, we have 58.97787 minus 19.56657 minus 19.6. So what do we have there? We have a 19.8113 over 12. So our acceleration will be equal to, when we divide this, we are going to get a 1.65 meters per second squared. Okay, so that's our acceleration. Then to find the tension, we're just going to grab our tension equation. We can even use that other one, this one, since it has tension. Where is it? This long one. Does this have tension? Yeah, this one we can use it if we want, but that would be complicating things. So let's take the easier one, which is this one. This one is we are having something like this. Then what we are going to do is that we are going to do that, then substitute. So tension should be equal to, when this goes the other side, it will be m1a plus m1g, like that. So tension should be equal to, m1 is common, a plus g, like that. So our tension should be equal to, what is our m1? M1 is equal to 2 kg. So yeah, 2 kg. So we are going to have 2 kg, like that. Then our acceleration is 1.65 meters per second squared. Then we have plus our 9.8 meters per second squared, like that. So tension is a force, so the units will be newtons. So we have 2 times 1.65 plus our 9.8. This is going to give us a value of 11.45. When we multiply this, we are going to get so times 2. This is going to give us a 22.9 newtons. So this is our tension for that problem. So here we are told, state 2 conditions for static equilibrium as the last question. So static equilibrium simply means to say the net force, or just the summation of the forces is the net force. So summation of the force or forces is equal to 0. So if you add the forces, they should give you a 0. So let's say if you have an object here, we have a force pushing. If this is 20 newtons, this is 20 newtons. If they are pushing like that, one has to be negative. Let's say this is negative. Then it will be negative 20 plus 20, which will give you 0. That's how come the objects will not be moving. So static equilibrium simply means to say the object is not moving. Last but not the least, if we have the net torque, so the net or the summation of the forces, of the torque, should be equal to 0. If those two conditions are met or reached. That means to say your object is in a static equilibrium. Remember, torque is a turning effect of the force. So let's say if you have an object like this, then you are expecting, let's say you have a force that is trying to cause an object to turn like that. You should also have another force that should be pushing up like that, so that if it is in static equilibrium, it will not be able to move, because the two torques tends to cancel each other. Let's say if this torque is 20 Newton meter and this one is also 20 Newton meter, the two tends to cancel each other to produce a zero net torque. So those are the two conditions for static equilibrium. Let's look at this last question. So we have something like this. We have let's look at it. So if we have this one, we have been told that a 5-meter uniform ladder of weight 150 newtons stands against a wall at an angle of 37 degrees above the horizontal as shown in the figure 4.2. There is no frictional force between the ladder and the wall, and the coefficient of static friction between the ladder and the floor is 0.5. An electrician weighing 700 newtons slowly climbs the ladder to fix the light bulb. He then senses that the ladder is at the verge of slipping and stops at the position X from the base of the ladder. Determine the value of X measured from the base of the ladder. So here what we are going to do is that, so for this one you can also watch the video where I solve many of these problems. So we are going to have something like this. Now this is under static equilibrium. We are going to have, let's say we have the wall there. Now you might wonder to say, why is the ladder not entering the wall? That is one important question that you need to understand. So let me draw it properly. So the question is, why doesn't the ladder enter the ground like that? Because if the ground is weak, the ladder will enter the ground like that. So therefore, there must be a force that is pushing up so that the ladder does not enter. This force, we are going to call it the normal force like that. Then at the same time, why doesn't the ladder, why doesn't the ladder enter the wall? If the wall is weak, it will enter as well, like that. So if the wall is weak, it might enter. Now the only reason why it is not entering is because there must be a force or acting on the wall in this direction. So the force on the wall like that. Then therefore, we are going to now come up with certain equations. So we have this force. Now the other thing is that if the person climbs too high, it will be able to slip like that. So like that, it might be able to slip. So meaning to say, the only reason why this is not happening is that there is a force that is pushing it towards the wall, which is the frictional force. It's preventing the relative motion between two bodies in contact like that. So with this, you are now able to solve the question. Now remember, the weight of the ladder is concentrated at its center, so we can write the weight of the ladder. Then also the electrician is also acting downwards, so we have the weight of the electrician like that. So let me just now write it properly. So what we have is the force on the wall. We have the downwards force, which is the force, the weight of the electrician. Another downward force, which is the weight of the ladder. Then we are also going to have the weight on the, which else? We have the normal force. Then we have the force in this direction, which is the frictional force like that. So this is our frictional force. So with this, we are going to begin with our summation. Let's begin with our summation of forces in the y should be equal to 0. It's not moving, so this one, it will always be 0. Since it's not moving, it's under static equilibrium. So we are going to have the one up is the the force, the normal force, which is our Fn there. So we are going to say the normal force minus our downward force is the weight of the electrician and the weight of the ladder. So both of these are acting in opposite directions in terms of the normal force, so you have to subtract them. It should be equal to 0 like that. So the normal force will be equal to the weight of the electrician plus the weight of the ladder if all these go the other side. The weight of the electrician, according to the question, we have been given that it is equal to 700. Let's move this. We have been given that it's a 700, so we are going to be using that value. So we have 700 newtons plus the weight of the ladder is 150 newtons, which will give us 850 newtons. So this is our force. So the force is equal to 850 newtons like that. Then we are going to have our Fy. Yeah, so with that, then we are going to go to the summation of forces in the x should be equal to 0 as well. It's not moving. Which forces are those? So if you look at this, we have the frictional force, so it is in the x. So frictional force minus the other force that is acting in the x is the force on the wall. They are acting in opposite direction, therefore you are going to say minus the force on the wall should be equal to 0. So the frictional force should be equal to, if this goes the other side, it will be the force on the wall like that. So then we know to say the frictional force is equal to the coefficient of static friction if it's not moving times the normal force. The coefficient of static friction according to this question is a 0.5, so we are going to say 0.5 times the normal force, which is equal to the 4, we found it to be 850 newtons here, 850 newtons. So our 0.5 times 850, so 0.5 times 850 will give us a value of, so 850 times 0.5, this will give us a value of 425 newtons like that. So this is our frictional force. So if this is our frictional force and we have said that the force on the wall is equal to the frictional force, therefore the force on the wall should also be equal to 425 newtons. So with this, we are now able to go to the next one, because to find the distance you have to account for the torques. So if you have something like this, then you want now to account for the torque. So after you are done with the forces, then you are going to account for the torque. Now the torque, if you are looking at the torque, the line that cuts the normal force, it's passing through the pivot. Let's say we set this as our pivot, shall produce no torque. Even the line that is passing through the pivot shall produce no torque. So these two forces are not accounted for. So therefore, if we have the wall there, what we are going to have is that we are going to get what are we going to get? We are going to get the force on the wall. Now you have to be very, very careful on the torque part. So torque is the turning effect of a force, and the torque is equal to the product of the force times the distance, the perpendicular distance that is. So what we are going to do is that we are going to get that distance. Now here you need to be very, very careful. Let's identify the ones that are producing torques. So the ladder itself, the weight of the ladder is producing a torque. So the weight of the ladder, even the weight of the person, because it's not passing through the pivot, which we have set as the contacts here. So the weight of the electrician, they are producing torques. And also this force on the wall is producing a torque like that. Now the force on the wall produces the torque in this direction. It wants to cause the ladder to more like go up like that. So therefore, we are going to account for that. Let's consider this convention. If you are going this direction, the torque will be positive. If you're going this other direction, the torque will be negative. So the one that wants to cause the torque to go in this direction is the weight of the electrician and the weight of the ladder. They want to cause the ladder to more like move like this. So we are going to say the torque is force times distance, so we are going to consider that. So the force in this case, it's the weight of the person, so it will be the weight of the electrician times the distance of the electrician, the distance where the electrician is. But this distance, remember, they have told us that it is equal to x, so we are going to have our x, so it will be our x d, our xd. Now we have to attach either the cos or the sine, which many have challenges. So let's look at it. So if you are looking at the electrician, the position of the electrician is let's say we have something like this. The position of the electrician, let's say, is here. You are going to extend the force that the electrician is more like causing, so it's like this. So this is the extension of the weight of the electrician. Then you are going to go at your pivot point, draw another line that is more like parallel, sorry. So we are going to have this. Then after you do that, you are just going to look at the separating distance. So the separating distance is from here. The separating distance between those 2 points is from here up to here, and the angle, we know that it's here. So since the separating distance is the base of the angle, then you are going to use cos. So we are going to say d cos of theta, like that. Then you have plus another force that is causing that torque is the weight of the ladder. So the weight of the ladder, like that. Then we are going to have times what is the distance. So the weight is concentrated at the center since it's uniform. So we are going to have if the whole length of the ladder is 5, if the whole length of the ladder is 5, that means to say from here up to here, if it's 5, then from here up to here it will be a 2.5, because 5 divided by 2 is 2.5. So we are going to say times the distance is 2.5. Then we are going to have our cos of our angle, which is our theta, which we are going to substitute. So here the distance of the electrician is x, so we can just say x like that. So with that said, we are going to have, so after that, so we attach the cos. So remember, the same approach works. So where the ladder is like that, where the ladder is down, you extend it down like that. If you extend the weight of the ladder is acting down, you extend the weight, it is going to be here. Then go to your pivot point, draw another perpendicular line, then see what is the separating distance. So the separating distance is from here to here, from here up to here. So this is our separating distance for that point. So if that's the separating distance already, the angle is here, so it shall be associated with the cos, like that. Then last but not the least, we have the force on the wall. So we are going to say the force plus the force on the wall minus, since it's in the other direction, so we are going to say minus the force on the wall times the distance, which is our 5. As you can see, the ladder, the force at which it is acting is 5 meters there. So if we have something like this, so if we have something like this, the ladder is acting at the point from the pivot, it is acting 5 meters away, because the distance from here up to here is 5. So we are going to say 5 cos of, now we are going to dissociate. We are going to have something like this. We extend this force, it will look like this. So this is the force on the wall if we extend it like that. go at your pivot points, draw a parallel line in the same direction as that, then look at your separating distance. So as you can see, the separating distance is from here up to here. So this is what is separating the two lines. So if that's the case, if this is the separating distance, your angle here is theta, then the opposite side shall surely carry the sine of theta. So you are going to say times the sine of the theta should be equal to 0. So that is how we do that one. So the weight of the electrician, remember now, let's get this equation. So it should be equal to 0. So the weight of the electrician is 700 newtons according to what we have been given. So we are going to say 700 newtons times the x cos of the angle we have been provided with is a 37, plus the weight of the ladder is 150 times the 2.5, then the cos of 37 degrees. Then we have minus the weight on the wall. The force on the wall is we found the force on the wall, if you recall, it's a 425. So we are going to say minus our 425. Then we have times the distance, which is our 5, times the sine of, so space there, let me reduce the font a bit, 5 times the sine of 37. Okay, 425 minus 425 sine of 37 degrees, like that. So it should be equal to 0. So what we are going to have is we are going to get a 700 cos of 37. This is going to give us a value of, so just cos 37 times 700, you are going to have 559.044857. Then we are going to have plus, we have 150 times 2.5 cos of 37. This is going to give us a 299.488. Then we have minus our 425 times the sine of 37. This is going to give us a value of 255. So we are going to get a, this times this, we forgot x, anyways I can just say times x. Okay, so let me write properly. So we have 559.045 x plus 299.488, then 425, there should be times the distance, which is a 5. So we have plus 425 times 5 sine of 37 degrees should be equal to 0. So we have 559.045 x, then we have plus our 299.488, then we have a minus here, minus, remember we have minus, so we have minus 425 times 5 sine of 37. This is giving us a value of 1278.86, which should be equal to 0. So we are going to get a 559.045 x should be equal to, we have a 1.1000. So before that, let's work out this. So we are getting a 299 minus that value, we are getting a 299.488. we are going to get a value of minus 979.372, which should be equal to 0. We take this value the other side, it will give us, so we have 559.045x should be equal to 979.372. we divide our value over our 559.04. over our 559.04, which is going to give us x is equal to, we have this divided by 559.04. This is going to give us 1.752 meters. That is from the base. So this is measured from the base. So it has to move from the base, which is here. The maximum should be 1.752 meters, like that. So that is that. Thank you very much for watching. So if you are new, kindly like, subscribe and share for more. You cannot afford to be missing such content. See you in the next tutorial.